A very good morning. My name is Shweta Shastri, and I'm working for Mallareddy Engineering College for Women, which is in Hyderabad. And today, I would like to give a brief introduction about data warehousing and data mining, which is a very interesting topics. And looking into the applications of it, the benefits of it, this subject is also a booming technology in the software industry. So the concepts are little easy and easy to understand and easy to implement too. Let's look into the definition of the data warehousing. The term data warehousing was first introduced by Bill Inman in 1990. According to Inman, a data warehousing is a subject-oriented, integrated, time-variant, and non-volatile collection of data. This data helps analysts to take informed decision in an organization. So, as the definition is clearly saying about the type of data that we are going to gather is all about subject-oriented. That is, the data that is surrounded by a real world entity. Okay, let it be like the general example that we can take is an employee or a product or any particular subject related data, and integrated plays the major role in the data warehousing. Integration means we are going to gather the data from a heterogeneous sources of data, nothing but we are going to integrate the data from different sources. Okay, from different sources. Let the data be in a flat file, so let the data be in an Excel file, or let the data be in any of the form. We are going to collect the data and we are going to integrate the data and we are going to store it in one particular place. And as the next word says, time variant. Time variant means the data that is related to some particular time frame. Like it can be a historical data, like few years back or few months back, or some time delay that you can give the data for some specific time that you're going to collect. See, and we are going to have a non-volatile collection of data. As the word says, non-volatile, the data that doesn't keep frequently changing. Okay. Finally, why do we need such data? Such data is needed in order to take some decisions for an organization. That means we are going to build a warehouse that is related to some particular organization. The data that can be from different organizations, they need analysts to analyze the data where we can use this data for a business purpose. That's the reason in the beginning I told you that it is the current running booming technology in the industry. Okay, so every application that has been developed or designed is specifically for business, right? So here we are going to speak about how we are going to gather the data. Subject-oriented, integrated, time-variant, non-volatile collection of data, which is used for the business decision making in any organization or an enterprise. Okay. And the data, we can see two types of data here. Why data warehousing and why the transactional databases that we. So an organizational database undergoes frequent changes on a daily basis on account of transaction that takes place. Okay, so that is the data that keeps frequently changing. That such data is called as operational database or a transaction or a transactional databases. But the decisions that when we want to make some decisions, the data should not be frequently changing. That's the reason one of the word that we used is non-volatile collection of data. So here, if you look into banking application, the banking application data is an operational data source because it keeps changing. The data that we see here, it keeps changing. Okay, so what type of data keeps changing here? The transactional data keeps changing. Okay, so we do have a little example of that. What is the difference between the operational data stores and the transactional data stores? Okay, and the data that is there in data warehouse is called as an analytical data processing, that is OLAP, online analytical processing tool. Okay, so here a data warehouse provides us generalized and consolidated data in a multi-dimensional view. In a little few minutes ahead, we are going to see the differences between the operational data stores and the OLAP. Okay, till that time, let's look into what exactly we are looking into data warehousing. Along with the generalized and consolidated view of data, a data warehouse provides us online analytical processing tools. Means the data that is used for decision making is nothing but analyzing the data, processing the data to take some decisions. These tools help us in an interactive and efficient effective analysis of data in a multi-dimensional space. Okay, so let's look into the differences between operational databases and data warehouse. When there is already the operational database existing, why do we go for data warehouse? Okay, why data, what is the need for database management system or operational databases to store data, and we go for the transaction there. And why do we go for OLAP? We go for we look into OLAP for analytical processing. Okay, nothing but analyzing the data. Okay, let's look into a few of the differences here. It involves historical processing of information. This is what in the definition it is said that time variant. Time variant is nothing but historical processing of information. Maybe 5 years back data or 6 months back data or a week data, some historical data. But whereas you look into operational databases, it involves day-to-day processing. The banking data that you see, every day you can see the transactions. Yes, every day some transactions are going on. So there is a flow of data. The data is not stagnated. The data is not stable in the OLTP. And the other difference here is OLAP systems are used by knowledge workers such as executive, managers, and analysts. So what does this mean? We are using OLAP for decision making. Who does the decision? The decision is taken by the executive, managers, and analysts, right? And OLTP systems are used by clerks, DBAs, or database professionals. Okay, so this is being used by a very few people, that is DBAs, who create the database. It is used to analyze the business. The OLAP is used to analyze the business, and OLTP, it is used to run the business. So what is the difference here when you talk about analyzing and running the business? Okay, so analyzing is used to take some decisions, analyze the data and take a decision to improve the business tactics or trends to improve the business. Okay, and coming to used to run the businesses, the daily transactions that goes on in the business. Okay, so when the data is running or flowing, no decisions can be done or made. Okay, then it focuses on information out, and it focuses on in data in. So the data that is stagnated or stable is called as a focuses on information out, the availability of the data, and data in. So when we do the transactions, we can see the data changing frequently. It is based on star schema, snowflake schema, and fact constellation schema. So now the data presentation in OLAP is based on the schema structures, that is the star, snowflake, and fact constellation schemas. Now we are going to present the data in OLTP in a form of an entity relation data model. Okay, we are going to represent the data in OLAP using the schema structures. Here we are going in OLTP, we are representing the database using ER relational model. And as it says, OLAP, it is subject oriented, specific to some particular real world data set. Okay, and it is application oriented. OLTP is application oriented, and OLAP, it contains historical data. OLTP contains current data. So what does this historical data mean? We can analyze the data based on some history. Yes, we can analyze the data based on the history. And coming to operational database, it contains current data. So the transactions are always on a current data only. The transactions are always on a current data only. And it provides summarized and consolidated data. That means the data that has been consolidated, that has been gathered in bulk and or in a huge quantity, and it provides primitive and highly detailed data. That means in OLTP you can find a very granular data, a small data piece where we can use it for a time being, and it provides summarized and multi-dimensional view of data. The view, the structure or the usage of the OLAP is represented in a multi-dimensional view of data. And coming to OLTP, it provides detailed and flat relational view of data. Nothing but it is a two-dimensional view of data where you can view the data in a form of rows and columns. And the data that is used in OLAP, in this one, in OLAP, it is viewed in a multi-dimensional data base. That is nothing but in a cuboid, the data in a cuboid. Okay, the number of users also we can differentiate here. Who uses more? The OLAP, the number of users is in hundreds. And mean very few people, that is the top management people like analysts. Okay, such people make use of the data. And OLTP, the number of users is in thousands, right? Many people like we have seen clerks, DBAs, and the designers of the data. They can make use of this OLTP. The number of records accessed is in millions. The number of records accessed is in tens. Okay, few only. But we here, since we're going for integration, we are going to access records in millions. Okay, and why the main reason lies here is the database size is from 100 gigabyte to 100 terabytes of data, and the data that is stored in OLTP is from 100 megabytes to 100 gigabytes. Means the volume of data is less in OLTP when compared to OLAP. And the data that is in OLAP are highly flexible. Okay, highly flexible. Now you're collecting data for analysis. So whenever you want to change your data based on the need and the requirement to analyze, you can have a data flexibility. But coming to the performance way, the OLTP provides high performance. The transactions are high performance. Now, how to store the data in a data warehouse? That is the big question mark. Like we have seen subject oriented, we have seen the data, it should be integrated, it should be non-volatile, right, and time varying type of data. So how we are going to take that data? Okay, let's look into little in depth. Like we are going to extract data from heterogeneous sources of data. And we're going to transform the data based on our need. And we're going to load the data into the data warehouse for pulling data out of the source system and placing it into the data warehouse. So now, how do you create a data warehouse? You create it by ETL tools or a ETL process: extraction, transformation, and loading. Extracting heterogeneous sources of data, transforming the data according to the user's requirement, and loading the data or delivering the data into the data warehouse, where once the data is extracted, transformed, and loaded, then only any top management person can take decisions for their business in an organization. So this gives a clear view, or it depicts how the transformations are being done. From where you're going to extract data, what are the sources for the extraction of data? So you can extract data from text files, okay, from CRM and from ERP data, and you can extract data from cloud, and this part is the extraction. These are the different sources of extraction. This data that is being extracted will or has to be transformed according to the user's requirement. Okay, it has to be transformed based on the user's need or condition or the requirement. And now the data that has been transformed will be loaded into the data warehouse, which is in a multi-dimensional view. So now here comes the data warehouse, where the data that you have kept will be used by the top management people. So let's see in depth a little further how such ETL process takes place. Extracting the data from different source systems. So what are the source systems? From where do you get the data? SAP, ERP, and other operational systems. Data from different source systems is converted into one consolidated warehouse format, which is ready for transformation processing. Okay, so now once the data is being collected or the consolidated data is available, then we can go for transforming the data. May involve the following procedure. Transformation involves the following procedures. So what are the procedures here? To transform your data, you need some derivations, calculations, new measures, and dimensions to convert or change data from one form to the other form which is in need. So how do you do that one? So cleaning is an example, mapping null to 0 or male to M and female to F. So now in some databases, you are representing male as M, female as F. So now I can convert this one into a unique form called male. I can give it as 0 and female I can give it as 1. Okay, then we can do filtering. One of the procedure or the feature that we can transform is filtering. Selecting only certain columns to load. I don't need all the columns that are there in the database, right? So the required database or data sets I'm going to take and transform that by using filter procedure. Okay, splitting a column into multiple columns and vice versa. The other procedure, joining together data from multiple sources like lookup and merge, transposing rows and columns. I can convert from rows into columns and columns into rows. Okay, applying any kind of simple or a complex data validation. Then loading the data into data warehouse or data depositories, other reporting applications. So this is one of the simplest way, like how a data warehouse is being created, and means this is a procedure that you can see. One is extracting data from different sources. Transforming takes place by cleaning, filtering, splitting, joining, transposing. And loading is nothing but storing your data into the data repository. So this gives the architecture. So now this can be called as a 3-layer architecture or a 3-tier architecture. Okay, so let's start the architecture from the bottom, where first you need to have the sources of data, right? Sources of data is nothing but integration of data. So where is the integration of data? So you get the data from operational databases, external sources, and it can be like flat files or ERP or CRM data, wherever the data is available, that will become the source data for us. Okay, then the data that is available there, now we have to extract, clean, transform, and load and refresh the data. As we have already seen the process of transformation, like few things like splitting, filtering, cleaning, transposing. Okay, so then such after the day, this cleaning, smoothing of data has been done, then it has to be stored into the data warehouse. So the bottom tier is the data warehouse server. Okay, you're going to store the data that has been extracted, cleaned, transformed, and refreshed, and it has to be loaded into the data warehouse. So how does the data warehouse now look? It will be, you can have a view of it in a larger volume or in the form of data marts. Data marts are nothing, they are the partitions of data. The granular or a detailed level of data in an organization is called as a data mart. Okay, so such data will be stored in, means the large data will be stored in a partitional way in a data mart. And then the data that is required will be stored in the OLAP server. So that is called as a middle tier or OLAP server. And once the data is stored in the server, then we have the top tier or the front end tools, where it will take the query or analysis or data mining, where the data will be represented in some pictorial representation or a chart forms or a report, some statistical way of representing the data. So this gives a view of the data warehouse. So it comes from different sources of data, then bottom tier, then the middle tier, and then the top tier. So the first layer is the source data, then the warehouse, then the server system, then the presentation layer. So this is how we are going to view the data. So these are the data warehouse components. As we have seen, how do we get data? We have to capture the data, transforming the data, aggregation and analysis, and presentation. The previous thing that we have seen here is represented in here in a componental view, like a simplified way of seeing how your data warehouse looks like. Hope you have understood the little small session that we have come across. Thank you very much.